Okay students, so now let us start the next problems of which we have solved in the last class. Clear? So now I am solving the problems from page number 7 of concept bank topic. Clear? Page number 7, you go through the concept bank. In that, this is our first question. So take your page number 7 and go on watching the video with your notes, so that it will be very simple to you students. Okay, so if you want to get the accurate answer, you have to read problem very carefully. Clear? You have to understand the logical terms very carefully, then you have to simplify. Clear? So first let us say this. It is from your sets topic. Clear? It is from your sets topic, page number 7, from concept bank. Let A and B be two non-empty subsets of the set X. That means A and B are two non-empty subsets. That means A and B contains minimum one element in it. Clear? And they are the subsets of X. See here, I will draw the Venn diagram, so it will be very simple. I will consider this is my X. Clear? A and B are the two non-empty subsets of set X. Clear? Such that A is not subset of B. That means if I take this as A and this as B, clearly you can see that A is not a subset of B. Clearly A is not a subset of B. Then which of the following is correct, they are asking. So A and B are the two non-empty subsets of the set X. A is not a subset of B. So I have considered one of the example of this particular problem. Okay. So now let us see what are the conditions. See, your first option tells that A is subset of complement of B. I have written the logical words here. In your textbook, they have written in words. Okay. A is a subset of complement of B, they are telling. Okay. Let us verify this with our example. A is subset of complement of B. What is complement of B here? This is B. See, this is B. What is complement of B? This complete thing will be the complement of B. This small portion will be not considered in the complement of B, because this intersection part is included in B. We need a complement of B. Complement of B means the other elements which are not in B. The other elements which are not in B. So this is B, and other elements which are not in B are the elements of complement of B. So now the shaded portion will be the complement of B. What they are telling? A is the subset of complement of B. A is the subset of complement of B, they are telling. So the shaded portion is complement of B. And now see here, this is A. If this has to be the subset of complement of B, each and every element of A must be in complement of B. That is what subset definition tells. What subset definition tells? Each and every element of set A should be present in complement of B. Then A is going to be the subset of complement of B. But if you see this Venn diagram, in this portion, the elements of B are present. Are you getting my point? So, these particular elements are not included in complement of B. Are you clear? So now, if I want to say my A, this is A. This A has to be the subset of B complement. Every element of A must present in B complement. But what makes you wrong here? This particular things are in A, but they are not in complement of B. Are you getting my point? This particular terms are in A. This particular terms are in A, but they are not in your B complement. So for that reason, A is not in a subset of B complement. First one is not your answer. Second one, see here, B is subset of A. Clearly you can see from the Venn diagram that this is B, this is A. Clearly from this you can see that B is not in a subset of A. This is also wrong. Okay. A and B are disjoint. See this. Here A and B are not disjoint. A and B are not disjoint. But what they are telling? A and B are disjoint, they are telling. Therefore, this is also not your answer. Then definitely option D will be the correct answer. Definitely option D will be the correct answer, because if you delete these three options, the remaining one is fourth. That must be your answer. But no problem. Let us look at that and verify it also. No problem. How you have verified with all three? The fourth option, let us also verify. Okay, because this system will be very quick in your exams. A and the complement of B are non-disjoint. Please understand. A and the complement of B. This is A and the complement of B. Complement of B is shaded portion. This is not complement of B. Are you getting my point? Now the shaded portion is complement of B. See, shaded portion is present in A also. A and the complement of B are non-disjoint. What is meaning of that? In set A and in set complement of B, there must be some common elements. There must be some common elements. From the diagram you can directly see that. See, the elements which are present here, they are in A as well as in complement of B. Therefore, set A and complement of B are non-disjoint. What is the meaning of non-disjoint? There must be some common elements between set A and the complement of B. So this particular portion gives you the common elements of set A and the complement of B. Therefore, option D is the correct answer. This is how you have to write your answers. Don't go through your notes. In that notes they have given something blah blah, very theoretical things. That particular things can't be solved in exam because it will be very lengthy. If you solve like this, it will be very quick and very fast. This type of techniques are important. So that's why the CET classes are important. Are you getting my point? In notes they can't give this type of techniques. They can write everything but they can't write this type of techniques. You can see that in your notes this particular technique is not present. That's why I am telling, please register your names very fast and fast. Are you getting my point? So option D is the correct answer. Let us go for the next question. Okay students, so now let us move for the second problem, that is a set contains 2n plus 1 elements. A set contains 2n plus 1 elements. The number of subsets of the set which contains at most n elements is. See, we all think that we are very good with our mathematics, but every examiner will be crossed our stage. That means he is going to cross the stage which we are now. Now that's why he is preparing the questions for exam. Are you getting my point? So already he knows how the students think. Already he knows how the lecturers can teach the students. Are you getting my point? So he keep that two things in his mind and he prepares the questions. So please don't be overconfident in any exam or with any questions. This is my simple tip for you whenever you are going to any type of exams. Because see here, as you all know, the formula for the power set is 2 to the power of n. and n are the elements which are present in the set. That formula we know. Okay. So see here, a set contains 2n plus 1 elements. A set has 2n plus 1 elements. Then the number of subsets. This makes us to be overconfident, because the number of subsets means what you are going to think? Power set. Power set formula is 2 to the power of n. N is the number of elements in the set. Here you have 2n plus 1 number of elements. So directly you are going to think the answer will be 2 to the power of 2n plus 1. 2 to the power of 2n plus 1, and you are going to choose as your option B as your answer. You are going to choose your option as B in the exam. Are you getting my point? But my dear students, option B is not your answer, because let us continue the question what he is asking. Because he is asking the subsets of the set which contains at most n elements. That means he need the subsets only which are having n number of elements. Are you getting my point? 2 to the power of 2n plus 1 gives you total number of the subsets. That is power set. But he is not asking that. He is asking what are the subsets in which it is containing n number of elements. What are the subsets in which it is containing n number of elements you have to calculate. Okay. So as you all know, the formula is 2 to the power of 2n plus 1. 2 to the power of 2n plus 1. I will use this and I will expand through binomial theorem. So what you are going to get? 2n plus 1 C0, 2n plus 1 C1, 2n plus 1 C2, plus so on to where? 2n plus 1 C 2n plus 1. Clear? So this is the binomial expansion of 2 to the power of 2n plus 1. Okay. Or you can write it also 1 plus x to the power of 2n plus 1. You can take x value as 1. So everywhere x value will be 1. So you will convert this as 2n plus 1 C0 plus 2n plus 1 C1, 2n plus 1 C2 plus so on to 2n plus 1 C2n plus 1. No problem. Here this can be written as C 2n plus 1 C0, 2n plus 1 C1 plus 2n plus 1 C2 plus so on to 2n plus 1 C n plus 1, 2n plus 1 C n plus 1 plus so on to 2n plus 1 C 2n plus 1. Just I am introducing the middle term of this particular binomial expansion. That's all. Here there is no big change. Only this first term, the middle term I have extended. Okay. After getting this, we know one formula, that is NCR will be equal to NC n minus R. NCR will be equal to NC n minus R. Are you getting my point? So for that reason, why I am giving that particular formula, that is also important. Okay. Why I am telling that formula? Because see here 2n plus 1 C0. If I apply this formula, 2n plus 1 C minus 0 will be equal to what? 2n plus 1 C 2n plus 1 minus R. R value is 0. So it will be equal to 2n plus 1 C0 equal to 2n plus 1 C 2n plus 1. That means your first term and the last term are going to be same. Here there is one hint. If I add these two terms, then it is going to be 2 times. Then it is going to be 2 times. Are you getting my point? 2 times of. I will write it as, see, I will write it as 2 times of 2n plus 1 C 2n plus 1. I will write that term here. Clear? Because these two terms are same. If I add that, there will be 2. So 2 times of 2n plus 1 C 2n plus 1. Plus so on to 2n plus 1 C 2n plus 1 minus 1. The next term. That means this is the term. The previous term of that will be what? 2n plus 1 C 2n plus 1 minus 1. Plus so on to. Are you getting my point? Middle term is important. See, before this what you are going to have, because this is the middle term. So before this what you are going to have? 2n plus 1, very common. 2n plus 1 C 2n plus 1 minus n. The term before this is going to be 2n plus 1 C 2n plus 1 minus n. Clear? That means what? 2n minus n is n plus 1. Okay. So this term is going to be n plus 1. Are you getting my point? So now what you had? See, here I have 2n plus 1, 2n plus 1 minus 1, so on to n plus 1. So these are the 2 times of what? This particular elements. Clear? Okay, no problem. But here one thing is important. What they are asking, set which contains at most n elements. But here we are calculating n plus 1 elements. No problem, no problem, because this is the half of what? Your total expansion. Half of the total expansion. This term is nothing but what? 2n plus 1 C0. This term is nothing but plus what? 2n plus 1 C1. Next so on to 2n plus 1 n plus 1. Are you getting my point? So I can replace these terms as 0 and 1. No problem, because these half terms are same as this particular terms. See here, already I have simplified. 2n plus 1 C naught is equal to 2n plus 1 C 2n plus 1 minus 0 using this formula. No problem. Clear? So now you got 2 to the power of 2n plus 2 to the power of 2n plus 1 is equal to 2 times of this particular terms. This is nothing but what? The number of subsets which are containing at most how many elements? N elements. At most how many elements? N elements. So now if you have 2 here, 2n plus 1, it can be expanded as 2n plus 1 into 2. Clear? So that 2, this 2 will be get cancelled, and your answer is going to be to the power of 2 to the power of 2n plus, sorry, 2n, 2 to the power of 2n, because this 2 and one of the 2 here will be get cancelled. This can be written as 2 to the power of 2n into 2, 2 to get cancelled. So the remaining thing here will be what? 2 to the power of 2n is equal to 2n plus 1 c naught, 2n plus 1 c1 plus so on to 2n plus 1 cn plus 1. Are you clear? So from this we understand one important thing, that is the set contains 2n plus 1 elements. The number of subsets of the set which contains at most n elements is 2 to the power of 2n. This is one thing. One more problems of this is I can write this as also n plus 1. I can write the same problem as also n plus 1 elements. Are you getting my points? I can just change it as a set contains 2n plus 1 elements. The number of subsets which contains at least n plus 1 elements. At least n plus 1 elements. The same answer for the previous answer and for the second, this question, both the same answer. Why? Because this half and this half terms are going to be the same. This half will be the n elements. The next half will be the at least n plus 1 elements or more than n elements. You can tell or more than n elements or at least n plus 1 elements. For that both answer is going to be the same, 2 to the power of 2n. 2 to the power of 2n. You can write it as same answer for both the questions. The first question was what? Only n elements, subsets containing at most n elements. Answer is 2 to the power of 2n, or it can be also asked as the number of subsets in which more than n elements are present. The same question can be asked as more than n elements. This is only n elements. More than n elements means next half. We know that the next half is nothing but the repeated of the first half. Clear? Because of this formula. Clear? Here 2n plus, here 2 to the power of 2n elements are present. Here 2 to the power of 2n elements are present. Are you getting my point? So be careful in exam for this type of question. For more than n elements also answer is 2 to the power of 2n. For elements containing exactly n elements is also the answer is 2 to the power of 2n. Because from binomial expansion. Clear? You see the video. If you understand, you see the video again and again so that the questions will be very clear. If you again get the doubts, you can ask me the questions. No problem. Okay. So let us move for the next question. Here the answer is 2 to the power of 2n. Okay students. So let us see the third question. The third question is, if A equal to x comma y, set of two elements, then the power set of A is. A very simple question. This type of questions never take any time. If you are perfect with the concepts which I have explained from the last class to the previous problem. This problem will be just like a bonus question for you in your exam. See what they are asking. If A equal to x comma y, then the power set of A. No problem. 2 to the power of 2. How much? 4. Clear? See, 4 elements were present in option D. Option D is your answer. Over. Otherwise, you can write subsets also. No problem. Empty singleton set x, singleton set y, set of x comma y. Very simple question. If the condition is, if you know the knowledge of the problems which we have solved in the previous questions. Okay. So very simple answer, that is option D. Clear? Anyways, it contains 4 elements. 1, 2, 3, 4. Okay. Let us move for the next question. Okay students, let us go for the next question. In the next question, what they are asking, if A has 5 elements, then the number of proper subsets, not only the subsets which are proper they are asking. So as you all know, the number of proper subsets is given by 2 to the power of n minus 1. This is the formula for the number of power subsets. Sorry, the number of proper subsets. What is the formula for subsets? 2 to the power of n. Power set formula. This is the formula for the proper subsets. So proper subsets means 2 to the power of n minus 1. So nothing but here you have 5 elements. 2 to the power of 5 is 32 minus 1. So your answer will be 31. Very simple. No problem. Clear? But you must know the formula. That is 2 to the power of n minus 1. Here also the explanation is not needed, because directly you know the formula for proper subsets. For if you know the formula for proper subsets, 2 to the power of n minus 1, 32 minus 1, answer will be 31. So option A is the correct answer. Okay. For collection of all the subsets, 2 to the power of n. For the proper, 2 to the power of n minus 1. What is proper, what is improper, let us see in some other classes. But here what they are asking, that let us solve only that much. That is the number of proper. The number of proper is 2 to the power of n minus 1. 32 minus 1. Answer is 31. Okay. Let us move to the next question. Okay students. Now let us move to the next question. That is, the set of intelligent students in a class is. The set of intelligent students in a class is null set, singleton set, finite set, not well defined collection. Okay. So what is the meaning of set? Set is collection of well defined objects, right? Suppose let us take, there is a class A or class B, class C or class D. If you collect intelligent students from the class, here the question comes, how you are going to measure the intelligence of students? At this point, I want to tell you one thing, my dear students. The marks what you get in your exam never determines your intelligence. The intelligence is different, getting the marks is different, getting the ranks is different. The student who is not getting the marks, the student who has failed can also be intelligent according to his circumstances. As you say, fish can swim under the water. Fish is very intelligent inside the water. Are you getting my point? Bird can fly in the sky and the bird is very intelligent whenever it is flying in the sky. But when the cases get reversed, if the fish comes in the air and if bird goes inside the water, both can't survive their life. Their intelligence doesn't work. That means in the same way, in every class, we can't measure the intelligence of students or we can't collect the intelligent students in one set. You can collect the students who are getting more than 90 marks. You can collect the students who are getting less than 35 marks. But here, intelligence, whenever the word comes, it will become an not well defined. Intelligence word is not an well defined element or well defined word according to our set definition in mathematics. According to a set definition in our mathematics. Because the student who cannot score more than 35 also can be intelligent according to his circumstances. The student who is getting 100 can be not intelligent according to the circumstances of others. Are you getting my point? So in that case, what we can say, the set of intelligent students in a class is not well defined, because someone can sing the song but he can't get the marks. Someone can score the marks but he cannot sing. So if you take a singing is the circumstances, there the difference comes. So like that, intelligence is a word which is not well defined according to our mathematics, but it is well defined with the English grammar. That is not the case. Clear? But when you come to the mathematics definition of set, collection of well defined means there must be no confusions whenever you are collecting the elements. Whenever you are collecting those elements, there must be no confusion in your mind. That's what called well defined in mathematics. Clear? If you are getting a confusion whenever you are collecting the element, that means it is not well defined. Clear? So that's why set of intelligent students is not well defined collection. Clear? So option D is your answer. Okay students, now let us go to the question number 6. That is, in rule method, null set is represented by. They are asking the representation of null set. See, the first option is only the null set notation. Directly you may answer this. Are you getting my point? But that is not your answer. Option B, it is also notation of null set. If you mark this is also not your answer. Why? Because here you have to understand the question off to the point what he is asking. What is off to the point what he is asking here? The point is in rule method he is asking. Are you getting my point? So for that reason, you must understand every question in your exam first clearly. Then you can answer it. Otherwise, it will be very, very tough, or otherwise it will be overconfidence. In these two, one thing will happen. If you understand the question to the point, then you are not going to get any overconfidence, or you are not going to get any doubts. Clear? So here in rule method, the null set is represented by. In rule method, the null set is represented by. This is also notation of null set. This is also notation of null set. But he is asking rule. There must be a rule defining that it is null set. Okay. So these two are the notations. They are not null set. Sorry, null set notation, but that is not rule. Okay. See this rule. What he is telling in this set. Please understand carefully. You have to read the defined set carefully, set of collection of x. Please understand it. If you don't understand what is written in mathematical form, definitely you are going to make wrong. Why? Because see here, a set of x, that means collection of x such that this x must equals itself. If I write one number in this set, that set has to be equal to itself. Are you getting my point? Please understand this. If you write any element in this x, that has to be equal to itself. Is it correct? Because in mathematics we know that if I take any real number, it is always equal to itself. 1 equal to itself, 2 equal to itself, any complex number equal to itself. Can you say that 1 is not equal to 1? 1 is not equal to 1. Can you say in real number 1 is equal to 1? Are you getting my point? So for that reason, 1 is equal to 1, 2 is equal to 2, so on you can go on writing 1, right? You can write 2, you can write 3, you can write 4, you can write 5, you can write 6, you can write 7, no problem, because 7 is equal to itself, 1 is equal to itself, 2 is equal to itself. So for that reason, this is also a null set, because it contains elements, it contains all the real numbers, all the complex numbers. Clear? Go to D. What is D here? Collection of x. Please understand how to read it. Collection of x such that x is not equal to x. That means x is a number here. What he is doing, he is collecting the numbers. He is collecting the numbers. Which type of numbers? Such that means which type of numbers? That number must not be equal to itself. X is not equal to x. That means number is not equal to itself. Is it possible? Can you write 1 in this? Can you put 1 in this? No. Can you put 2 in this? No. Can you put 3 in this? No. Can you put any real number in this? No. Because every real number is equal to itself. Every real number is equal to itself. So for that reason, option D will be empty set. Option D will be empty set because it contains no elements. It contains no elements because every number is equal to itself. Okay students, so now let us go for the next question, that is, in rule method the null set is represented by, these are the 4 options, no problem. In rule method the null set is represented by what they are asking. So please understand the question off to the mark, because if you see option A is also empty, option B is also empty. Directly you can take one of this if you don't understand the question carefully. If you understand the question carefully, then there will be a patience in solving that particular problem. If you don't understand question off to the mark, I am saying, because null set everyone knows. These two are getting my point. In advance you can get any of this question and you will get the no mark, because off to the mark they are asking, that is means rule they are asking. They are not worried about empty, they are worried about the rule method. They are asking rule method where null set is represented. In rule method it has to be represented. Clear? The first option is null set, but it is not rule method. Second one is also empty set, but it is not rule method. Clear? Now let us go for the third one. X such that x is equal to itself. Please see, is this set contains any element? Yes or no? Can I write 1 here? I can write 1 because 1 is equal to 1. 1 satisfies this particular condition. What the condition is here? X equal to x. X is equal to itself. That type of x has to be written in this set. Can I write x value as 1? I can write x value as 1. No problem, because 1 is equal to 1. I can write 2. I can write 3, I can write 4, I can write any real number. I can write any real number in this set. I can write any complex number also in this set. No problem. Because those particular numbers are always equal to itself. So what is meaning here? This set contains element. This set contains element. It is not empty. In this there are more number of numbers. There are many numbers. You can write any real, you can write any complex or anything because it is equal to itself. So for that reason, it is a rule but not empty. They are asking rule which gives you empty. Okay. Now let us come to this rule. See, all these three are deleted. Definitely fourth one will be your answer. No problem. Okay. But let us understand it. X such that x not equal to x. See, you know 1 equal to 1, but 1 not equal to 1, mathematically not correct. 2 not equal to 2, mathematically not correct. Are you getting my point? 3 not equal to 3, mathematically not correct. Are you getting my point? So, 3 equal to 3 is correct, but 3 not equal to 3 is not correct. If it is not correct, I can't write here. The condition which satisfies, I can write here. Because x and x both are same. What they are telling? X is not equal to x, they are telling. That means a number which is not equal to itself. That kind of numbers you have to write here. Is it possible? Think once. Can you write any number which is not equal to itself in this particular set? You can't write any number because every number is equal to itself always. It is a simple mathematics, a basic mathematics of LKG. Are you understanding my point? So x not equal to x, that kind of numbers cannot be writing in this particular set. You can't write that particular elements in this set. You can't write that particular numbers in this set. What if you can't write? What is meaning of that? This remains empty. And it tells a rule. Rule empty. So rule method the null set. That means this is a rule with null set. Clear? So for that reason, option D is the correct answer. For the rule method, the null set is represented. In rule method, the null set is represented. This is one thing. Okay. So like that you can write any rule. But in these four options, this is one example. Like this you can write many number of examples. Clear? I will write one more. X such that x is natural less than 0. X such that x is natural less than 0. Can you write natural numbers less than 0? No. Or can you write natural numbers less than 1? No. Are you getting my point? So x is a natural less than 1. That means here also you are not going to get any numbers. This is also rule and this is also empty. But this is not given your options. Like this you can write many rules to represent empty set. Clear? But in these four, option D is correct. Okay. Okay friends. Now let us go to the next question. See how beautifully they are asking the questions. Very, very beautiful question. Why I say very, very beautiful question means no one without knowledge cannot understand this question. That's why it is beautiful. If you have knowledge, you can understand that. You read this question and try to understand itself. For itself you can understand. Already you have studied the theory concept in 11th standard relation functions chapter. Clear? Already you have studied it. Already you have studied special type of functions. Already you have studied the graph of e raised to x. Everything you know. But try to understand, can you answer this question? 90% of students cannot answer this question without having the knowledge. That means they has to read more and more and more and more number of books. Then only they can answer this. Otherwise, it's not possible. Very simple question. Very, very simple question. But 90% of students cannot answer it. That's the beauty of this question. That's why I am saying this question is very beautiful. Why? Because see here, A set is collection of order pairs x comma y such that y equal to e power x. A function is exponential function. Function is exponential function for real numbers. He has given for real numbers for 11th standard and 12th standard. We study every function on the real graph. That's why no problem. That higher level of x belongs to C complex. That type of questions never possible here to ask. But no problem. Real numbers makes it something more simple. So what he is telling, y equal to e raised to x. Y equal to e raised to x. X belongs to R. That means exponential function. Elements for x collected and its images collected. Are you getting my point? X e power 1. X is 1. 1. E power 1. That is collected. Clear? This is 1 comma e. 2 comma e square. 3 comma e cube. Like that. Clear? Here 1 e power minus 1. 2 e power minus 2. 3 e power minus 3. Like that. Okay. So that type of things are collected in A and B. Then what they are asking? Then which of the following is correct? A intersection B equal to empty. A intersection B is equal to 0 comma 1 single order pair. A union B equal to R square. That means real number square. None of this. Okay. Most of the students go for none of this because they are, one thing, they are not going to understand the question. Second thing, if they understand, they can't possible to solve. Those kind of people go for none of this. Clear? Let us solve this. Very, very simple. First you draw e raised to x. This is e raised to x. Clear? Next you draw e raised to minus x. This is e raised to minus x. What is the meaning of e raised to minus x? Mirror image across y-axis. Mirror image of e raised to x across y-axis will be e to the power of minus x. If this a simple knowledge if you have, you can draw this where they are intersecting at this point. What is this point? 0 comma 1. So this is a single common element, single common order pair which comes common for both e to the power of x and e to the power of minus x. If this is common for e to the power of x and e to the power of minus x, definitely option B will be your answer. Because intersection means what? Common for set A and common for set B. If 0 comma 1 is common for both A and B, so for that reason A intersection B equal to 0 comma 1 will be the answer. See, very simple question, but without knowledge not possible. Clear? Okay, let us move for the next question. Okay students, so now let us move for the next question, that is 8th one. Clear? So this is also a very beautiful question because again, as you all know, if you have the knowledge of that particular topic, then only you can understand the question. Otherwise you can't understand this question. Okay, if you understand the question, then only you can answer. Otherwise what happens? There will be one option, none of this. Everyone will go for none of this. Without understanding the question or without solving the question, most of the students go for none of this. But when you have a knowledge of that particular topic, this question will be very, very simple and it's a very beautiful question. Let us say this. See here, if P is one set and Q is another set, what are the elements in P? Elements in P are the real numbers. Elements in Q are also the real numbers. But in the set of P, the real numbers which makes f function as 0. In the set P, real numbers which make a set of f as 0. That means P is a set with the real numbers where the function f is going to be 0. Next, Q is the second function where it is again with the real numbers such that G function is 0. That means they have given you two functions f and g. So f and g are going to be 0 for some real numbers. So whenever f is 0, they will collect it in P set. Whenever g is 0, they will collect it in Q set. So next what they are asking, then what is P union Q? They are asking. Okay. So P is collection of all the real numbers which makes f function as 0. Q is a set of real numbers which makes g function as 0. Okay. P union Q means P union Q set must contain all the elements of f which makes 0, all the elements of g where g makes 0. Clear? So that collection has to be in P union Q. Have you understood the question? P union Q means in P union Q you must have all the type of elements which makes f function as 0, and Q is the set where the elements are present which makes g function as 0. P union Q means these two elements which makes f as 0 as well as which makes g as 0, that has to be present in P union Q. So they are asking P union Q. Now let us go for the options. What are the options? See, x belongs to R. X belongs to R. F of x plus g of x is equal to 0. F of x plus g of x is equal to 0. Here what happens with option A? Let us take one example. F of 1 may be 0, but g of 1 may not be equal to 0. Are you getting my point? Because f and g are the two different functions. F and g are the two different functions. I will consider f of 1 is 0, but according to this, g of 1 may not be 0. Are you getting my point? If this happens, here f of x will be 0, but g of x will be not 0. So the sum will be not equal to 0. Then these elements are not going to present in this particular option A. Are you getting my point? Option A tells you what? Option A tells you the sum of these two must be equal to 0. Then only you have to collect the x. Then only you have to collect the x. Are you getting my point? So option A tells that f of x and g of x both together has to be 0. F of x and g of x both together has to be 0. That means there is no difference between f and g. There is no difference between f and g according to this particular option. Are you getting my point? If there is no difference between f and g, you can call both as f function or you can call both as g function. But what is set? See, they have written two different sets, P and Q. In P only f which is 0. In Q only element which makes g as 0. If you consider this, what happens? Both f and g will be the same functions. Are you getting my point? If you solve this equation, what you are going to get? F of x equal to minus of gx. From this you can say that f of x and g of x are also not the same functions, or you can take this example. There also you get that is f of x and g of x are not the same functions. Clear? According to P and Q also f of x and g of x are not the same functions. Okay. So option A is not your answer. Clear? Come to option C. Again they are making the square of f of 1. If I make square of f of 1 square is 0. If I make g of 1, the square of that number which is not equal to 0, again it will be not equal to 0. Clear? Any number which is not equal to 0, you make a square of that, again it is not equal to 0. So therefore option C will be also not your answer. Okay. Now let us come for option B. If this is also not your answer, then none of this will be your answer. Okay. But let us check this. According to this, see, you have two options. F of x and g of x will make you 0 with product. What this product tells? Either f of x may be 0 or g of x may be 0. In these two, any one of 0, the output will be 0. Are you getting my point? From these two, if any one of this function is 0, the product of that will be definitely equal to 0, because as you all know, anything that multiplied with 0 will be equal to 0. Are you getting my point? Suppose f of x is 0, g of x is not equal to 0, but multiplication of 0 into not equal to 0 will be equal to 0. Second case, suppose g of x is 0, f of x is not 0, but 0 into not 0 again will give you equal to 0, a simple concept. Okay. So what happens here? For all x belongs to R, which f of x is equal to 0, will give you, implies f of x into g of x is equal to 0. So one of the set is already solved, that is f of x. Now you have to solve for g of x. What about g of x? See, for x belongs to R, which makes g of x equal to 0, implies f of x into g of x is also equal to 0. Are you getting my point? See, if I take this set, in this set, for every x belongs to R, here also for every x belongs to R, which makes f of x as 0, it implies f of x into g of x is also 0. Here g of x may not be 0, but because of f of x, it is going to be equal to 0. Product of this is going to be equal to 0. Come to this. Suppose for all x belongs to R, g of x is equal to 0, f of x may not be equal to 0, but product will be again equal to 0. So what happens here? The elements x which makes f of x as 0, as well as element x which makes g of x is equal to 0, both are present in option B. The elements which makes f of x 0 is also present. Elements which makes g of x equal to 0 also present in option B. So for that reason, option B will be the correct answer for this particular question. See, a very simple mathematics asked through this question. Okay, but who have the knowledge, they can answer. Without knowledge, you can't answer. No problem. So understand this question, understand the concept, understand the function f of x and g of x. Then you can go through this particular solution. Now I will move for the next question. If you have any doubts, as you all know, please clarify with me through the message or through other method by coming to the college. Okay students, now let us move for the 9th question. So it's a very simple. Just you must know the two formulas of A minus B, Cartesian product with A intersection C. Okay, what is A minus B? Elements which are in A but not in B. What is the meaning of A minus B? Elements which are in A but not in B. Are you getting my point? That is what? Your A minus B. Okay, so elements in A but not in B. What are the elements in B? 4, 5, 6. So leaving these elements, the elements of A. See, 1, is it present in B? No. 2, is it present in B? No. 3, is it present in B? No. Then what is A minus B? It is going to be equal to 1, 2, 3. Okay, elements which are in A but not in B. Next, A intersection C. A intersection C means common elements. What are the common elements? 1 and 2 are the common elements. So A intersection C is equal to 1 comma 2. So now make Cartesian product in between what? A minus B and A intersection C. So the Cartesian product will be what? Equal to 1 comma 1, 1 comma 2. Directly I will come here. See 1 comma 1, 1 comma 2. Next 2 comma 2, 2 comma 1, 3 comma 1, 3 comma 2. So these are the elements of A minus B cross A intersection B. Okay. So what are the elements present here? So therefore the answer will be none of this. The answer will be none of this, because 1 comma 1, 1 comma 2, 2 comma 2, 2 comma 1, 3 comma 1, 3 comma 2 has to be present, but those elements are not here. So for that's why your answer is none of this. Okay. Okay students, 10th question. As you all know, this is a very simple question. So just you make union of B union C. What is union of B union C? Write all the elements of B and elements of C. It will be B union C will be equal to B union C will be equal to what? A, B, C, D, E. This is B union C. A, B, C, D, E. Clear? Make an intersection with A. Now intersection with A will be equal to what is A? A, B, C. So output will be A, B, C. A very simple question. So answer will be A, B, C. That is your option E. So in this type of questions, don't waste more time. Very simple question and bonus type of questions. Let us go to the next questions. Okay students, now let us go for the next question, that is A and B are two sets, then A union B complement union A complement intersection B. Okay, let us draw the Venn diagram. First let us take, this is A, this is B, A, B. What you have? A union B complement. So what is A union B complement? This is A union B complement, right? Next what you have? A complement intersection B. What is A complement intersection B? A complement intersection B is this particular thing. Okay. A complement means elements which are not in A with B. A complement intersection B. Are you getting my point? A complement means all this portion leaving A. You leave this A. You leave this A. Remaining all elements will be in A complement. Intersection B means what you are going to get? Only this particular elements. Okay. Next. So this is equal to what? See, this is equal to what now? Elements which are not in A but in other set. That means elements which are not in A is present with this Venn diagram, which are present. Elements which are not in A are present. What is the meaning of elements which are not in A? The meaning of elements which are not in A is nothing but A complement. Clear? So A complement will be the correct answer. First you draw A union B complement. That means you leave A union B. You shade the A union B whole complement. That is with blue. That is blue is what? Your A union B complement. Next you draw A complement intersection B. So this particular portion will be what? A complement intersection B. Okay. Now A union B whole complement union A intersection B means blue and this B. Complete is present. So this is the Venn diagram of A union B whole complement union A intersection, sorry, A complement intersection B. This Venn diagram tells what? Nothing but A complement. See, elements are not in A, but they are in other sets. That is meaning of what? Elements are not in A means what? Elements are not in A means A complement. Okay, elements which are not in A is nothing but A complement. Clear? So this is what your a very easy answer. Okay, let us move to the next question. Okay students, now let us go for the 12th question. That is, let A equal to x such that x belongs to real numbers, mod of x is lesser than 1. No problem. B set is x such that x belongs to real numbers, mod of x minus 1 is greater than or equal to 1. That means here you must know how to solve the mod function. First thing. Next, and what they are asking, A union B. Elements in A and elements in B they are asking. Okay. So A union B equal to R minus D. A union B equal to R minus D. Then the set D is what? Okay. So they have given A union B equal to R minus D. R minus D means real numbers. Elements should be in real numbers but not in D. R minus D means elements must be in real number set but not in D. They are asking. Okay. So first let us calculate A union B. Okay. Then let us calculate R minus D. No problem. For that, what is necessary thing? Set A and set B has to be decoded, or set A and set B has to be solved. So mod x lesser than 1 is nothing but x is lesser than 1 greater than minus 1. That's what mod function tells. X is lesser than 1 and x is greater than minus 1. You go through the mod function which we have taught in the 11th class. There in detail we have mentioned mod function. So if you want to remove this mod, that mod gives you what? X is lesser than 1 but greater than minus 1. On the same way, what is meaning of this? I will draw a number line. See, this is minus 1, this is plus 1. X is in between minus 1 to plus 1. This is your x. X is in between minus 1 to plus 1. Minus 1 and plus 1 are not included because this is open interval, not closed interval. Okay. Next, mod of x minus 1. That means mod of x minus 1 is greater than or equal to 1 and x minus 1 is lesser than or equal to minus 1. That's what your mod function tells. So if you again simplify this, it will be x is greater than or equal to 2, or next one x is lesser than or equal to 0. Because if I simplify this, minus 1 goes on this side, plus 1, minus 1 plus 1, 0. Minus 1 goes on this side, it will be x is greater than 2 and x is lesser than or equal to 0. I will also draw a number line of this. This is 0, this is 2, x is greater than or equal to 2, it goes this side, x is lesser than or equal to 0, it comes on this side. Okay, now what I will do, I will make union of these two number lines. I will make union of these two number lines. What you are going to get? See here. Somewhere here you are going to have 0, no problem. Here you are going to have 2. Okay. Greater than 2. Clear? Lesser than 0. This thing. So now lesser than 0 or greater than 2 elements are present in A union B. Are you getting my point? See, you have minus 1 to plus 1 from set A, lesser than 0 and greater than 2 from set B. If I make union of this in A union B, what elements you are going to have? See this. In A union B, you are going to have the elements lesser than 1 and greater than 2, which is not present. See this. This is 1, open interval. This is 2, closed interval. Okay. So now from this, you understand that open at 1, closed at 2. That means 2 is included, 1 is not included from this particular length. So from the total real numbers, you are removing D. That is going to be equal to A union B. This D has to be removed. This D has to be removed means D will be equal to what? X. See this. X is greater than 1, that is open, lesser than or equal to 2 is included here. So in D, 2 will be not present. Here 1 is not present, it will be present in D. Are you getting my point? Because in our union 1 is not present. Just because, see this, it is open interval. In our union 2 is included. Just see this, because it is closed. 2 is in our A union B. 1 is not in our A union B. So that's why 2 will be not in D. 1 will be in D. Clear? What is D set? That is A union B equal to R minus D. A union B already we know. See, lesser than 1 elements but not 1. Lesser than 1 elements but not 1. And greater than 2. Greater than 2 with equal to 2. Because see, 2 is present. See here, 1 is not present. Are you getting my point? So for that reason, lesser than 1 and greater than 2 are present in A union B, but the elements from 1 open at 2. Elements from 1, it is in D. That means there it will be closed. From 2, that means 2 will be open. See, now this will be the length of X where 1 is included, because it is not in our A union B. Where 2 is not included in, 2 is included in B. So for that reason, here 2 will be not present. So D will be in between greater than or equal to X, lesser than 2. So your answer will be what? That is option B. Okay. So very simple diagrammatical solution. No problem. In textbook they have given some theoretical solution, but no problem. You understand this. Very simple question. Okay.